Okay, welcome to this session. I'm going to talk about Mimer SQL. A lot of it is in general, but also some of it specific for OpenVMS. Okay, so let's see. Yeah, page. Okay. So I'm just going to give you a little bit of background and then talk about product features and our latest released version, go into some of the features that we added there. And then we'll deep dive a little bit onto the VMS platform and see what we're doing there. And then I'm going to talk a bit about what we're doing right now and what we're developing and working with, just to give you a glimpse of what's coming. So that's the plan. Okay. So we're a Swedish company based in Uppsala. I was at the Bootcamp in Boston in the fall, and then you really needed this little to show where on the map we were from, obviously. So we've been working with database systems for a long time. The Mimer product actually started in the 1970s. And we were on VMS in 1983, I think. PDP 11 before that, and a lot of different platforms during the way. Quite broad product. We both have solutions for very small embedded systems up to very, very large systems. So we have customers with tons of data and tons of users, and then we have very tiny users as well with very restricted memory. So what we're doing spans all of this, which is a challenge, but also a lot of fun when you implement these things. We're about 15 people in development, and or I think we counted 13. Well, somewhere around there, and many people have been around for a long time, but we're getting new young people. I actually employed a girl, 26 years old, last week, so we're which is nice. So, yeah. Yeah, okay, so it was VAX 1980. We've been on all the different VMS platforms. We were on VAX to begin with, and Alpha and Integrity, and then now x86. We've actually had OpenVMS, or VMS was used to be called, as our main development platform. So that's where all the developers were working. Today, we're a little bit more distributed. We actually work in parallel on a number of different platforms. So some developers are on Windows, some on Linux, and some on OpenVMS. So when we develop something new, it's actually run on all these platforms within half an hour or 15 minutes when you check something in. So the product is highly portable that way. And it doesn't really matter what platform you're on when working with this. Okay. I'll talk a little bit more now about the product features. So it's a database, and with database, it's always a lot about performance. Without that, it doesn't matter what else you have, actually. So that's something that comes in. With performance comes scalability, being able to grow from small to large and build larger systems. I think when we designed the system to begin with, we actually looked a lot at how we wanted the system to be self-maintaining. in the 80s and at that time that you really needed to have people with white coats handling your system and taking care of everything. But we really built into the system to begin with that it should do its work by itself. You shouldn't have to pat it and help it along. And I think many of our customers can witness to the fact that this is very, very true. In other systems, they've kind of added this on top, trying to squeeze it in afterwards, but it's not that easy to do it the right way, though. With, for example, the reorganization free means that the trees are always balanced. So it doesn't matter if you insert or delete, whatever you do, it will always maintain a nice structure. And that's really important for systems where a lot of data is coming through the system. If it just grows, it may not matter as much as, but for example, we have customers that keep, like telecom operators that keep SMSs in this system. So they're coming in, they're passing through, and then they seep out. And they're huge amounts of data, but it's constantly growing and regrowing. But you don't run any utilities to clean up trees. You don't do anything. This is always, they're always kept in shape. And this is good for availability and for performance, obviously. Another thing where we differ from other systems is the few system parameters. I think in some systems there are a few guys in the world that can tune an Oracle database with whatever parameters that there are. But in our case, we've always looked at each kind of tuning thing. See, can we do this ourselves? Can we build in this automatically? Can we make the system do this instead of requiring complex understanding of the product? So I don't know exactly how many parameters we have today. I think it's around 20, rather than having hundreds or thousands. Okay. Yeah, I talked about the portability. Over the years, we've been on, I'd say, hundreds of operating systems. So this is just some of the more that are maintained and ported to. Yeah, I'm giving you some examples of real-time operating systems and embedded systems, but there are other systems like this that we run on. And there are various processors on various systems, obviously. Okay, so here's just oh, I had a slide about this. Okay. This is about the automatic reorganization. So this never happens in Mimer. It always grows completely, stays in shape all the time. Actually, you may say, oh, but doesn't this cost a lot? But actually what happens is, first of all, there's lots of optimizations going on with regard to IOs and when you need to write different nodes to disk and things like that. And the other thing is that this is actually done mostly in the background. The actual update of the whole entire database is done in the background. So when you do a transaction and you commit the transaction, you get control back and you can see everything that you did, but we've actually not done anything yet. And that's done by background threads doing all this work. And they're actually the ones doing the reorganization. So
at least you should have written some transaction log to the disk.
Say again?
But at least you should have written a transaction log.
Of course. So the transaction database contains the commit, and that's obviously written to disk when you commit. So we can always recover, we redo these things if the system goes down. Yeah. Yeah, another important thing is a feature we developed for one of our large customers who happened to be here today a few years back, something we call immediate restart. What we noticed was when the system went down, when you came back up, it took a while because it started checking the database and making sure that everything was all right. But when we did this, we could actually you even though the system is crashed, you can actually start the application immediately and start working and using it. And we tried to get the customer to actually tell us also how long did it take, but they forcibly crashed it once. And they said we could not measure any time, it just came back immediately. So it actually worked out pretty well, I think. And this is also something that even if you do this and you have a node switch, so if you're in a cluster and you have two nodes and you start the database from another node using the database on the shared disk, this feature is very important for the failover to happen quickly. As you can understand, we've been developing the system for 40 years, so there are lots of database features that we've implemented over the years. So I picked a few just to show you what we can do and what the system does. One thing that we're really good at is sorting data, and that means sorting data according to language rules in different countries. So we have support for around, I think it's actually 160 languages. So and when we did this work, we actually corresponded with professors all over the world in linguistics to actually find out how to properly sort these things. Today, it's very much governed by the Unicode standards, but when we implemented this, that was not did not cover as much as they did today. So you can actually sort independent of case, or sometimes in some languages, several letters are sorted as one. Sometimes a single letter is sorted as several letters. And if you think about it, maybe you might think this is easy, but how do you sort Swedish letters on Iceland? Because knowing how to sort the languages within a country, you may be able to figure that out. But how do you sort other characters from foreign countries here in Sweden or in Turkey or in whatever language we're using? So that's a big challenge, and we've done a lot of work with that. We've also done fair amount of work on pinyin and Chinese sorting. Actually, one of the most difficult languages is Vietnamese, because they don't have consonants. It's very hard to tell where words start and end, and that type of things. There's a lot of knowledge built into the system with this. And it's really easy to use because you just say, if you say order by column, collate Vietnamese, and then it will be sorted according to it. And you basically have two modes. When you select data, maybe you don't want, it doesn't matter if you have upper or lower case. So when you compare, you use one collation. But when you sort it, you want it nice and proper and accents coming out sorted. And then you use a little bit more strict collation in that case. So you typically use one for where clause and another for the order by. And you can then also use the collations with the secondary indexes because you want to be able to do this fast, both the sorting and search. Okay, that I just picked, very, very few features, but so let's see what we've done in this version was released 2 years back, I think. This was actually a very performance release from our point of view. We did a lot of things to improve performance and scalability, and did a lot of work on the SQL execution engine and optimization. And so I'm going to show you some benchmarking that we did on this release, just to give you an idea of this. When it comes to benchmarking, it's the Transaction Processing Council. They've set up standard benchmarks for databases, and it's very strict on how you run them and how you audit these things. So we're not allowed to call this TPCH really, but what we've done is we've set up all of these systems in the same way. They've been optimized by someone else. We brought in the MySQL and Postgres and so on. So in this case, maybe I have some, yeah. So you can see there are 22 queries. These are quite advanced OLAP queries, I would say. Lots of aggregations and tricky searching. And actually, each one of these queries they've been really thought through. So they really pose a challenge for a database developer. And one thing you should remember, all the vendors, they've been running these tests, trying to optimize their systems for these tests. So it's not that we're if I could easily set up a benchmark that we're winning, but that's not what we're doing here. We're taking this advanced query test that everyone else has done more work than we have to optimize their systems for this. Okay, so, and you can see that we want fast response time. So in this graph, you want the low bars here to be able to be good. So I have a summary here of all the queries, so you can see. Actually, the large commercial vendors from the States, they don't allow you to publish any benchmarking information. So I've written it this way, but I was actually very impressed by their performance. I didn't think they were that good. So that's a bit of a surprise, but you can see that we're in this query benchmark, we're 3 times faster than Postgres, and MariaDB and MySQL are not doing well. And we're slightly faster than the large commercial vendor, which is a lot more expensive than our system. So
a little bit about the queries. What kind of query is it?
Well, the query, it's a lot of aggregations and a lot of decimal numbers that they're using in complex expressions. So there's a lot of counting and yeah. But all the queries are tricky in various manners, and you can use different indexing methods to speed them up. But they're not easy to do right. No. But you can actually look them up on the internet. These 22. I mean, they're publicly available. So yeah, if you Google TPCH, you will see them. Yeah. Okay. So that was query, and then we did a benchmark on transaction throughput. Same systems. So this is a TPC-C. In this case, you kind of have a system with a heavy transaction load and everyone hammering away. And there are a lot of hotspots in this test, which means that many transactions are updating the same row, which is difficult from a transaction point of view to get scalability. and you measure the benchmark measures there are 4 different transaction loads that are happening simultaneously, and they're called A, B, and C, and D. And the benchmark, when you report according to the council, then it's the C transactions that you measure. So that's the blue. And when you include all the different, the 4 different transactions, then you have the combined graph here. So you can see that you're getting a much higher throughput with Mimer than all the others. So now you have both the query side and you have the transaction processing side, quite different challenges, very different how you make a system fast on these things. Yeah, you can see the database was, you can scale the TPCC according to your wishes. This was with 38 million rows in the database. We're doing exactly the same things in all these systems. Same load, same benchmarking transactions. So, and we've not written the benchmark. So we're just plugging Mimer into it. I did a little summary here just to, so you can see this is, if you want OLTP, you want it to be fast. And with the query, you can see here, I kind of turned this graph around compared to the benchmarking before. But you can see that the blue here, for example, that was the large commercial vendor. We were almost the same as Mimer on the query side, but when it comes to transaction processing, we're lots and lots times faster than them. So historically, we've not actually done that much benchmarking against competitors. So we were really surprised when we did this. So we were really proud about these figures. Okay. So this is the version 11 that we used for these benchmarks. We've done a lot of different things to increase scalability. We used to have a limit on the database cache, which is the part where you keep the database in memory, put the database on disk, and then you cache part of it. So the database cache had a limit before of 16 gig, and we raised that to 327 terabytes. So maybe it will last even for 10 more years. And the file size per, which basically amounts to how big a table could be, was 8 terabytes, and that went to 4,096 petabytes. So that should also be fine for a while. There are no file systems or disks that match this at the present time. So I think we'll be fine for a while. We're very much into standards. You can see here we're actually the only system that's 100% core compliant with SQL 23. Actually, Postgres is close. They're missing 2 features, but the others have a larger discrepancy. And then there are also extensions in the SQL standard. We have 145 of those. We added another utility called DB Analyzer, and it goes into the database and looks at your indexes and things like that, and suggests if you have overlap or if one is unnecessary because you have another index, or if you have both a primary key and an index that overlap, or things like that. When we did the utility, we had no idea it would be so important, because lately we've been working with RDB conversions to Mimer. And RDB has a slightly different way of looking at indexes. So if you just take the indexes you have in RDB and run them in Mimer, the analyzer finds lots of indexes that it can get rid of. So it can do this automatically when you combine these two. The utility can also look at a live system and show you the index usage. So you can kind of get a picture of when you have your applications running in production, what indexes are used and how much. We have something called a data bank, and a data bank has basically corresponded to a file on disk in Mimer. And you can have one or several tables in a data bank, so then they share space. But sometimes you run into an I/O bottleneck, and you want to be able to distribute your load. So in that case, you can add another file to your data bank. So that's what we did in this version, which means that, I mean, effectively, if you have them on separate actual disks, you can actually double your I/O throughput by doing this. The application doesn't know about this. I mean, it just does insert or whatever. So this is completely transparent for the applications. And it automatically load balances so that it spreads out over these files. And you can add a file while the system is running. And we kind of thought about this. It was actually a way so you could actually, during production, you could actually move a file from one disk to another, because you just add a file here and then you drop the original file. And it will just move over there. So that was kind of a side effect that we got pleasantly surprised about when we did this. We have client-server encryption. This is a good example of our way of thinking about parameters, ease of handling the system. Because if you want to use client-server encryption in Mimer, you just set in the server, okay, I want communication with this server encrypted. That's it. Then it will be encrypted, and you don't have to install certificates, you don't have to install this or that, and you don't have to mess around with this. It just works then. You can, if you want to use older clients with a new server, they don't know about encryption yet. So you can say whether you allow that or not. But that's really the only tweak on this parameter. You can see here that each session gets a unique encryption key. So it's really tough for someone attacking a system like this, because even if they manage to break the encryption on a single connection, he'll have to start over on the next one. Or if this connection goes down, that specific encryption key will not be reused. Yeah, and it uses standard AES GCM encryption. The reason for that and why that's important is that there's almost always hardware support for encryption decryption, which makes this very, very cheap. So it actually, when we've done measurements, you can hardly measure that you're actually using encryption. It's around 1% or something on the throughput. So it's really nice when you have the hardware support for this. We created an in-memory server, which means that it starts with a database that you have. It can be empty, or it can contain data or tables. And then you can just run towards this server, and whatever you're doing is created in memory. So it's a way to do lots of analysis or whatever you'd like. You can actually save your data by taking an online backup, but otherwise it just throws it away when you stop the system. So it's really It is an in-memory server, but if you do an online backup, you can retain whatever results if you want to do that, or you could just connect to another database and store it there. And again, the application doesn't know about this. We actually use this a fair amount during testing because it runs really fast, obviously, and it processes exactly the same commands as any database server. So even though you do create data bank, which actually should create a file in the system, it behaves as though there is a file, but there isn't. So. And with a large buffer pool, you know, the 327 terabytes, I mean, you can have substantial amount of data in your system. Okay. Yeah, so that was version 11. Just a quick information about that. So let's take a look at OpenVMS. As I said, we're a system that's developed on this platform for this platform, not ported from somewhere else trying to use VMS features. We've done lots of integrations with regard to communication and synchronization and shared memory and threading and whatever else. Yeah. We were the first database to release on OpenVMS. We had our first release 2 years ago, 31st of March 2023, way ahead of anyone else. And I know Camille in the previous presentation said that, well, the debugger on x86 is not so good, he said, but it was not good at that point, I can tell you. You could not use it because it crashed the whole time. So, but the way we actually managed to do our port was that we discovered that if we ran our tests, we actually had the same behavior on Itanium and x86. So if we found a problem on a x86, we debugged it on Itanium, and then it worked on both. And I was actually amazed about the compatibility. I mean, absolutely bug compatible too. So that's how we could do the ports so early, because the debugging and everything else was not in place really. I mean, since then they made several updates of the compiler, so it's actually running a lot faster today, obviously too. But yeah.
What about the capacity on x86 battery integrity? Is it faster? Or?
Yeah, I don't know if, I mean, we've not had the largest Itanium machines, but I mean, so for us, it's definitely run a lot faster on x86. Okay. But I don't know. I mean, if you have really nice Itanium systems, I mean, you have quite a lot of CPU power there. So, but I mean, the architecture is simpler with regard to shared memory, for example. I mean, it's harder with a RISC-based system it's much more complex to handle things. There are a lot of nice assembly instructions on x86, which we can utilize to get performance at the very low end. Because, I mean, we have so much multi-threading and so much shared memory and so on. So how those things are integrated in our system has a big impact, are really important. Mm-hmm. Yeah, and you can see that the source code that we have, it's exactly the same on both platforms, actually. But we're not, if we change something, it goes to both of them. And we actually port to both of them also. Usually in parallel too. So. Yeah. Here are some examples of clients that we have. We have something called Mimer API, which is our native client. Then we have JDBC for Java, ODBC, embedded SQL for C, Fortran, and COBOL. We have something called module SQL, which is basically embedded SQL, but you've taken the SQL and put it in a file on the side, and you make calls to. So each SQL statement has a subroutine name that you call, and so instead of doing exec SQL open cursor, you call your open cursor, and it's a module SQL. But what that means is that you can support other languages like Pascal, for example, or if it's something that we don't have embedded for. So we have a Python client. We have lots of different clients, but they cannot always run on OpenVMS, like Rust or .NET or Qt client driver. So, but you can use those on your favorite platform and access your database on VMS. Okay. Okay, good. Just gonna talk briefly about performance monitoring. We have several different tools to. There's something called SQL Monitor, so you can see who's using the resources in the database server. You can kind of pick out what SQL statements are the server working on, which are more expensive than others. That's actually available both as a graphical utility and command line based utilities. You can run it remotely also, so you can sit on one platform and do this. So you can have your graphics on a Windows workstation and look at your VMS system and see what's expensive, what's happening now. We have T4 support, which is typical VMS performance monitoring format, which means that you can both get operating system metrics and Mimer metrics together, and you can kind of see, oh, when it slowed down here, we had this disk activity going on here, or the CPUs were bogged down over here when we were seeing things here. So it's really nice to be able to combine these. You can also see that with the Windows Performance Monitor, where you have both. If you're running the server on Windows, you can see Windows statistics and Mimer together and see what's happening in the system. But that's possible again with the T4 here. Yeah, oh, I'm running ahead of myself, I see. Oh well, skip that. Okay. So now I'm going to talk a little bit about what we're doing right now. We've actually worked quite a while on this version. So we have lots of things that are actually done already by this. But I'll just give you some ideas what we're doing here. We are adding support for encrypted database files, which we haven't had before. Grouping sets is our advanced SQL constructions for doing more OLAP operations. We're adding temporary tables. SQL window functions you can do Excel-like functionality with running averages or running sums and that type of thing. There are quite a few window functions. So I think we've been looking at 11 window functions, and they each require separate optimizations and nifty things to do these fast. So quite a bit of work to get that up and running properly. In Mimer, we had a root user called sysadm, but we're now allowing that to be any name. So an attacker can't be sure that it's always sysadm he should go for when trying to break into the system. We're looking at a lot at different clients, look at failover support to make it easier for clients to be in high availability environments. And we've done several different things on the indexes. I'll talk about that soon. And then we've also added external .NET procedures. So you can write code in C#, for example, and then you can call that function from your SQL. So it kind of integrates into the SQL, which may be interesting in some cases. So for example, you can have a trigger that calls a C# procedure that does something that we would never add to the procedure language itself.
It's .NET support for Linux, but what you're gonna do in VMS?
Yeah, that's right. But we've not done this yet, but we're thinking that you could actually host your procedure server on a Linux or Windows and call it from VMS, even though the bit of a cost for that, obviously. Yeah, but who knows? If they succeed enough, maybe someone will port it to. Okay, so let's just take a little peek at these different areas. The encryption, what we're doing here is very much, you have something we call a recovery key file, and that you use that to do the actual encryption of the database. But you only need to do this once per hardware. So if you keep your database in place, you just initiate your encryption, and then it will keep running on this machine. But if you take the database to another machine, it won't work. You will need your encryption key to unlock it in the new environment. So this is again thinking, we're really trying hard to make it easy to use these things, because it's easy to requiring passwords or encryption keys or stuff, but then it gets harder to use the system, and it's really a challenge to combine ease of use with security. So we've really been thinking about how we should do this. The nice thing with the recovery key is you don't actually keep it on the machine where you have your database. You just have it there, and then you unlock the system, and then you remove it. So if someone actually hacks into your system, steals your files, they don't steal your recovery file. But if you need the recovery file quite often, then you're going to keep it there anyway. So I think it's a good idea that we're doing this. We're using something called TPM to store the encryption key, which is a hardware low-level module. Again, it depends on the hardware, whether this is available or not. So we're really taking care not to disclose these things unnecessarily. The TPM is actually not even accessible from the operating system. It's like its own little piece of hardware. Again, we make it simple. You encrypt everything, because otherwise you say, okay, I want this file encrypted. Then you're doing transactions towards this file, and then you're keeping records in the transaction data bank, and you're not thinking about this. So you're actually, if that file is not encrypted, then, or you're doing a SQL statement that's sorting something, and part of the sort ends up on disk somewhere. You don't want that encrypted as well. So rather than giving the choice of making these errors, we're just saying, let's encrypt everything. And again, most of the writes in a Mimer system is done in the background, which means that the encryption, when you're going to write it to disk, is not something that affects the user performance. The only I/O you're actually waiting for is the commit I/O. Okay. Yeah, again, it uses hardware acceleration just as the client server encryption does. And when we measured this, it costs about 1% of overall performance to have it encrypted. So I'm suspecting everyone will use this that have vital data, which most people do. So, okay. Backups are also encrypted. But then you have to kind of think about these things. If you take a backup and then you turn encryption on and then your disk crashes, then you have to be able to combine encrypted with unencrypted in some situations. And same thing, if you turn encryption off, you can still use your encrypted backup. We're trying to take care of these situations. Okay. Yeah, so that was encryption. I'm going to talk a little bit about the improved failover. What happens is that if a database connection is lost or the machine where the database server is running is stopped somehow, then we want to start another database server. But what do applications do in these cases, and how do they handle it, and how does this affect applications? And when you start to look at it, there's actually some parts of this are really tricky. Actually, when we thought about it, we thought we should build some knowledge into our software to help this along. And I'll just show you what this looks like. So we have actually 3 different cases. You have an application and it's not running in a transaction when the server goes. Well, in that case, the application won't notice everything because the client knows that, okay, it's lost its connection, it's reconnecting to the newly started server, and it can just transparently do this for you. So you don't have to do anything in the application, and it won't even notice when this happens. The second case is that, okay, we've started a transaction, we've done a few operations, and now we lose contact. So in that case, you have to roll back your transaction, basically. You have to understand, okay, something bad happened, I have to redo my transaction. So when you do something, you'll get a specific error code, and then you can just say roll back and redo your transaction. And then you're in, like in the case 1, then it will automatically reconnect for you, but you still have to forget about the transaction you were working with. And then you have the third case, that's when the application has called commit. How do you know what happened then? Because the commit call may have come to the server, it may have been done before it went down. It could have been saved on this, but you don't know. And this is the really tricky case for applications, because if you consider an application, you may have hundreds of different transactions that you're doing. If you kind of, after commit, would have to figure out, did it do my transaction or not, by kind of probing for values or something, that would be very, very difficult, specifically in a multi-user environment. So what happens in this case is that we actually keep a specific identifier for the transaction. And when we reconnect to the new server, we can ask the server, what happened to this transaction I was working with when you went down? And it will tell you whether it was committed or not. So from the application point of view, you do your commit, lots of things happen, we reconnect, we ask the server, and then it may come back and say, oh, there was a rollback. Or it may say, yes, your transaction was committed. And you don't have to do anything else. So by having this support, it's completely transparent for the application. But if you don't have this support, it's very, very difficult to program an application correctly to handle this case. So this is really what we kind of been thinking about. How do we help our customers with this? So, no. Failover, implementing this is a big job for us because you actually have to do it for each client. And as you saw, we have a lot of clients, so it will be a phase when we kind of implement these in the most important clients to begin with, and then eventually have the support everywhere. That's okay. Jonah, I'm going to talk a little bit about the indexing in Mimer. I'll just briefly update you on what we have already. An index can be on one or several columns. You remember you can have a collation on one or several index columns. Or there's something called a word index. So if you have text in your character field, then it will index each word in that text. And you can search for that. And we also have a current collation index, which means that if you switch collation, the index will be rebuilt using the new collation. This was heavily used on mobile. We were on Sony Ericsson's mobile phones. And when you changed language on your phone, all the indexes, you only had one set of indexes and they were updated. So that was done automatically then. We have something called pinyin indexes for searching Chinese text. And then we also have a location GPS data type that we have coordinate indexes for. So this is what before version, the version we're talking about now. So here comes the next stuff. So these are the new. So we're adding so that an index can have extra include columns. So if you look at this query here, we need the index to find the A equals 10, but we don't. We want to solve the entire select by just looking at the index without going to the base table. So by having the B column included, we can actually solve the B here. If we didn't have the include, we would have to go to the base table to find the B. Then we're adding indexes where nulls are not stored. And this can be interesting if you have like matrices with data where you have lots of null values. Or it can be interesting if you have, let's say you have many customers that have lots and lots of data, like millions or billions of rows in their tables. And then, but you only need to act, for example, you're selling something new, then this needs to go through ordering and packaging and selling and billing or whatever. And then, so you keep an index on a column where each of these states are indexed. But then when you're kind of done with it and you don't care about this row anymore, at that point you set the column to null. So the index, even though we have a table with 1 billion rows, the index may have 500 rows. You can kind of do smart things with it. Obviously, you cannot use the index if you say column is null. If you say A is null, it will not use the index because it will have to scan the whole table to find it. Before indexes had to have an exclusive lock on the table when we created them, but now we're going to support that on the fly, which I think larger sites will appreciate. Okay. And then we're doing this is actually coming out of all our RDB conversions. We're actually doing something called a clustered index. In Mimer, what clustered index means that the index that is clustered is used in the base table as the key. So there can only be one clustered index per table. And in Mimer, that has always been the primary key. But we're finding all these RDB installations where they just have a unique and no primary key. But the unique, if you have a not null on that column, you can make it into a primary key. But if you allow null values, that's not. So we want to make it easy. So in this case, you can say create clustered unique index, and that will be your base table index. So yeah. So we're kind of looking at improving migrations from other systems, but also enhancing what existing customers are getting here. Oh, 56. I'll hurry up then. Let's see how much. I have 2 left. We actually implemented a new numeric package. So we have a new format for decimal. And the old type that we have is called numeric. So a customer can pick and choose. But the new format is faster when you're doing computations, and it uses less space. So, but it's completely compatible with the old format. So you can just upgrade your database, have your existing format, and then you can add this for new tables. And yeah. And you can mix them and whatever. There are no restrictions. You cannot tell that this is happening. If you're using the new decimal type from an older client, we will automatically convert it to the old format so that the client will not be disrupted by this. Okay. Yeah, external procedures. I talked about this, having C# procedures. I'll show you the next one. So it looks like this. When you do an SQL statement that references a procedure, you actually call a procedure server. The reason for having to do this is that the database server has lots of privileges. It can access files more than it has privileges in the operating system and so on. So we could not put user-written code in here because that code would be privileged. So we have to do it this way, even though it's a bit more expensive than running it inside the server, obviously. But yeah. But again, then this could be this could be OpenVMS, and this could be running on Windows. I even have an example. I realize this is a bad example because this is something you can do in the stored procedure language. But here we're converting from Fahrenheit to Celsius in a little C# procedure that we've written. And then we tell the system what library is this in, language CLR, and then you create your function and declare any parameters and return values. And then you can use it in SQL. Or you could do a select D from F or set or whatever, or in a where clause or wherever you can have function calls. So that's, yeah. Yeah. Oh, I have more pictures. Would you like me to stop? 14, 15. Oh, okay. All right. I'll just show you. I think you realize I have some more. We just released a new data provider with enhanced security and some other stuff. We're doing something called DateVMS, which is actually an RDB data type that we've added to Mimer to make RDB conversions.
When did you release that then?
The data provider? A week back or 2. And we're doing connection pooling. I think that's been asked for by our customers too. So that's coming in the next version. Another thing is that we've been looking at upgrading from older versions of Mimer. And with version 11, it was the first time we actually broke compatibility. We've been compatible since 1987 database format up until this version, but it meant we had to reload the database. And so what we're doing here now is allowing customers with large databases to upgrade without too much downtime. So you can take a backup of your old system, then you upgrade the backup. And then when you've done that, which may take hours or 40 hours if you have terabytes of data, then you can apply the log of the running system to top it up to do what you did in the last 24 hours when you were upgrading. So this is and that may take 20 minutes or 30 minutes. So we're kind of getting the upgrade downtime down for this. We're not going to be incompatible again for another 20 years. But we have to solve this at the moment. Yeah. This is the RDB migration kit. Yeah, we've done lots of stuff to be able to migrate people off of RDB. We have lots of interest in this. And we actually have a translator that goes into the application and translates SQL, embedded SQL in the application. And we can automatically get the schema over to Mimer. We can unload the database from RDB and get it into Mimer and change the application. If you're using dynamic SQL, then you need to rewrite some parts of your application. But otherwise, you can actually do all of these steps automatically. So, yeah. But let's not talk about this anymore. Okay. So that's it. If you want to give me feedback on this, you can scan the QR code. There are 2 questions, so it's not too much. Okay. Sorry, took a little bit too long. All right. Thank you very much for listening. Yeah.
Developing under and for VMS, what kind of function do you use? RMS record access function or block access function?
Block access.
Block
Yeah,
access.
yeah.
Yeah. So you don't use any RMS function?
No.
Only block?
Yeah.
Because
it's
I'm developer, it's interesting for me.
Yeah, I mean, you go down a level basically.
Yeah.
And most people use something called reserved memory because you pre-allocate this memory for the buffer pool cache.
Yeah.
Then it's very efficient when there's no paging.
Yeah, so now I
also
understand
the IO.
how do you manage the problem of a concurrent access to the same file? That's a big issue for ODB5.
Mm-hmm. Yeah. Good.
Because we have tried to fix, and we really fix this issue in SSIO shared stream IO project.
Mm-hmm. Okay.
I have worked with this project 5 years ago.
Okay.
In the Russian team. So we have done it. We have checked it. We have debugged it, and
we're thinking about
nothing happens. Unfortunately.
Okay. I see.
Sometimes.
Yeah.
Great. Yeah, I have spoken to him. I've told him to do that.
Are you able to run the same?
Because we have
To split resources, or is it just a failover?
So we
Just
done
failover,
all of these
but that's
curriculum and
up for the
everything
next
on the same machine.
version after this.
Otherwise,
But
these
that's-
benchmarks are
we don't have that.
Yeah,
at the moment.
But
we handle quite large loads anyways.
But I mean,
So, but we
Microsoft
cannot
sends a
scale
lot
to
of
the very
information,
big
so they are-
systems
they're
because
getting
of that.
closer to-
But
So there's only
for
Microsoft
example,
that wanna
the ones
fucking-
that left, they have
Yeah.
3,000 concurrent users.
No, that becomes your problem.
Yeah, but I get
So
it.
quite-
You can run 3,000 users on single node
That's it.
systems.
Yeah,
That's
sure.
with
Yeah,
any of the big data
yeah, of course,
databases.
of course.
That's not the
Yeah,
problem
no,
anymore.
no. That's right.
Hardware is big enough in
Yeah,
the meantime.
that's right, that's right, yeah. Mhm.
And do you have some functionality for duplicating database to remote sites or something like for disaster situations where?
I mean, on VMS, our customers typically
In
use,
general, yeah.
we have something, a replication system, but it's on a table basis. So that it kind of, whatever you're doing, but it's not in sync, it's
Okay.
slightly lagging, so you're
Yeah,
kind of pushing the changes.
So you're pushing the transaction logs, or you're pushing some of the data blocks, or what you're pushing
No,
there?
we're actually storing them in the database, and a program is pulling things across.
Hmm.
But in the next one, we have dual systems, then it will be the transaction log that we're pushing across. Yeah.
Yeah, interesting. I didn't know
Mhm.
before. I'm doing databases now since
Uh-huh.
I don't know when.
Okay,
So,
all right. Yeah.
I had Ingress on Vex VMS in 1990, and a little bit RDB and lots of Oracle.
You know, I actually visited Ingress because we were doing an Ingress gateway.
Yeah.
And
Okay.
this was 91, I think.
Uh-huh.
Well, around that time
Yeah,
anyway.
Ingress 6.4 on the.
Yeah, so
on
I
Vex,
actually
yeah.
went there and they said,
Uh-huh.
Ingress is the fastest database, they said. And then I said, okay, now we've set up the gateway, we can run an Ingress application.
Mhm.
And they were sure they were going to beat us because Ingress goes directly and talks to their server, but the gateway is,
Yeah, sure.
but we still run much faster than that. So that was actually, they were truly shocked by it.
Did you show the benchmark?
Yeah.
Yeah.
Why they were sold to computers also.
Yeah.
And then
They actually
Reds in
offered me a job, but I didn't take it.
Oh, yeah, so great.
So how did it go?
Well, don't ask me. Yeah.
Good.
I have too many slides. It's always like this. I cut down and cut down,
Yeah.
but so
Again, thank you.
okay, thank you. Okay.